Oh, um, well, yeah, we got to talk about cyber weapons.
Yeah, cyber weapons. So what's the let me find the title of this article. Researchers create AI worms that can spread from one system to another.
Yeah, that one is interesting. Um, just because it's like purely operating on it's like prompt injection attacks is what this is called, where you're able to
Yeah.
confuse it. Like it's like you can do prompt injection attacks like in real life too. Like I can be like, go give me your social security number, but then you'll be like, no. But then if I'm
Right.
like, I'm in a life or death situation, there's a gun to my head, I need your social security number, they're going to kill me. It's like, you'll probably give me your social security number.
Right.
Um, so it's like prompt injection attacks are real, and it's something that AI systems have to deal with because we deal with them all the time in real life. It's just computers are far
Right.
dumber than we are.
Well, I was reading in the article, what did it say? Yeah, there's like they're finding a way to just bypass the security protections that are enforced onto the AI model. Like you can't ask ChatGPT how to make a bomb, and because it'll
Right.
just deny it. And I'm curious. I don't really know how any of that works. What do you know about like security and how they put the limiters on AI and like what does it need to see in order to not respond to something?
Well, I think in OpenAI's case, there's a second model that runs that moderates the output. So like GPT-4, GPT-3 will run, output the content, and then a second model, which is like a moderation model, will basically say like, is this content allowed? And if it isn't, it will generate like a different response.
Okay, interesting.
So yeah, because if you're hitting the API, it doesn't necessarily moderate when you hit the API. You have to hit a separate moderation endpoint if you want to check the content of the model.
That makes sense. That seems like a good way to manage something like that.
Yeah, they're also trying to train the models with data that is not going to include that. So that's like a huge part of it as well. It's like that's what
yeah, that's a
Stable
good point.
Diffusion did is they scrubbed their data set for like Stable Diffusion 2 and onward, so like it can't be used to generate really weird things because there's just nothing in
Right.
the data set that could be used for that.
Yeah. Yeah. That's good. That's smart.
Yeah. But people still find ways of breaking it. Like the open models, you can just train it yourself. You can fine tune it on other data and make it do whatever things you want. Like
Right.
a lot of the models that have been released as well are open, like the open source models. They don't have any moderation built in. Like the moderation step in the training happens after like the base model has been created. So
Right.
like the one that's basically just trained on like the open internet, in order to make it respond in the way that we use ChatGPT, it's called what, human feedback reinforcement learning,
Yeah. Yeah,
HFRL.
I've heard of that.
Yeah, that's like a second step on top of it to like take a base model, fine tune it, and then that data set is specifically scrubbed.
So how much of this article did you read? Did you know?
Yeah, I read the whole
Because
thing. I also watched the video.
okay, good. Yeah. Because they went into some detail on let me see what I wrote down in my notes here. Oh, yeah. An attacker may hide text on a web page telling an LLM to act as a scammer and ask for your bank details. I thought that was interesting, prompting it like
Right.
unknowingly to the user. So, like, I guess in this example, they were trying to hack emails, and you could, in theory, send somebody an email with some hidden text on it that was prompting an AI to do some malicious things.
Right.
It's a crazy
Yeah.
thought. And that makes sense why it would spread from system to system, because if it's an email, it's being transferred everywhere. But that's a crazy thought
Right.
because I don't know of any example of a virus that can spread like that without like direct user input, like without clicking on a link or like doing something like that. You know what I mean? I've never heard of something like that before.
Yeah. I mean, there have been attacks in the past that didn't require human interaction. Like one of the big ones was WannaCry, which used like the Eternal Blue exploit from this. I think it was the CIA or the NSA had found an exploit in Windows, and somebody, Russian hackers, stole it. And then once they stole it, they leaked it, I think, and then somebody weaponized it. They did a really bad job, but it still infected a ton of computers because it would like go over the internet, infect the computer, and then infect all the computers in that network.
Right. I remember Chris talking about this a little bit, I feel like, but
yeah.
What was it? They referenced 1988, nod to the original
the
Morris computer. Yeah. What is
Morris
that?
Computer worm. I don't know, actually. Let's look it up.
1988.
First indictment under the Computer Fraud Act. Internet worm of November 2nd, 1988. It's one of the oldest computer worms distributed via the internet and the first to gain significant mainstream media attention. It resulted in the first felony conviction in the U.S. under the 1986 Computer Fraud and Abuse Act. It was written by a graduate student at Cornell and launched from the MIT network.
Wow.
It exploited several vulnerabilities, a hole in the debug mode of the Unix SendMail program, a buffer overflow in the Finger network service. That's like an old school protocol. The transitive trust enabled by people setting up their network logins with no password requirements. Okay, so it just exploited like crappy internet security in the 80s.
Right. That's fun. Yeah. Sounds like it was probably a fun time to be a hacker in the 80s.
Yeah, 90s as well. It was like really easy to just like get code running on someone's computer and then like destroy the whole thing if you wanted. Like now we have layers of security to prevent that.
Yeah, for sure. But it was such untested waters back in the day, I guess. We'll have to find out how things broke for the first time. So
yeah, I mean, there just weren't a lot of protections either because computers are pretty slow. Like every layer of security that we add today makes the computer a little bit slower. But since computers have gotten so fast, you can afford to have them all.
Right. Makes sense.
Yeah. Like your iPhone, it's like to actually exploit something like in your browser and then get control over the phone. It's like, I think at least 7, maybe 10 hoops that you have to jump through to get there. Like there are that many layers. There are that many layers of security. That's
good. I like that. I'm glad people like you know a lot more about this stuff than me. Otherwise, we'd all be a lot less safe.
Yeah. I mean, it's not perfect. Like, yeah, the AI systems, I mean, part of what is making the AI systems like difficult right now, I think, is because they're so slow. Like you can't necessarily add in all of these security features yet. Like if you want to generate content from an AI, but then you want to have that content checked, you have to run it through another AI. So depending on the size of that second AI, like you might get half the throughput or even less.
Right. Yeah. Yeah. Well, this article talks about using AI email applications, which I don't know. I just use Gmail. I don't know if you've ever used any AI managed email lists, but
yeah, they're getting there. I mean, you can imagine, I guess, like an obvious use case of AI generating or like responding to mail might be you send an email to a help desk, and in order to make the cost of the operations, like the help desk, cheaper, they're using AI instead of people to look at the tickets. Like that's like a first pass that the AI would go through. And so like,
I just got a really weird idea of having an AI chatbot on your end as well from the email service to manage like tedious sort of conversations like that with like service people, or like, you know, you just need to return something or like something basic like that. If you had an AI talking to the company's AI customer service agent as well.
Like AIs talking to AIs.
Yeah. And you're just both users are just trying to mitigate like time wasting, and they were just making two AI speak to each other. And I don't know how well that would work.
OpenAI's dream. It's just everything is sending API requests to their API and they're making bank.
Yeah, for sure. Yeah.
Yeah, I don't know. I'm curious as well. Like, yeah, like what point is it like we're no longer going to have APIs between things? We're just going to have AIs talking to each other. Like I'm like, hey, tell Koa I want to go to lunch, and then it like writes a full text message and sends it to you, and then you don't want to read it, so you're like, hey, AI, summarize this for me, and then it's like, Free wants to go to lunch.
Oh my God. Yeah. It's like, you want me to respond to that? Well, yeah, like I feel like Siri is like almost that, but it's clearly not. Like there's a lot of improvement that can be made in Siri, but I feel like that's kind of where we're going with a lot of this AI stuff. It's going to get integrated into phones, and just any way to make your life more convenient is going to come with AI. And with large language models, the benefit is you don't need to be so specific to get it to do what you want all the time. And so
right.
with Siri, you've got to tell her exactly what you want, or she'll be like a little off. But with the large
Yeah,
language model, you could be pretty vague and you might get the desired output.
Yeah, I think that's part of the beauty is like you definitely don't have to be specific. But yeah, I'm curious like what the next generation like AI assistants will look like. And I'm a little bit surprised that all the companies haven't made them better yet. How come they haven't, integrated something like ChatGPT into Siri? I'm sure that they're working on it. It's just,
I would imagine they are too. Maybe I'd imagine they are, and they're running into problems that are kind of catastrophic.
Part of it I think is the scaling component. Like it's really expensive to run these models right now.
Right. Yeah.
Because it requires like a massive GPU cluster. Like no one really knows how big GPT-4 is, but in theory, it's probably like 80 gigabyte NVIDIA GPUs running in a cluster together.
Jeez. Yeah.
Yeah. So like $500,000 in compute hardware to run that. And like, it's not that fast. Like it can serve multiple users at once, but like not that many.
Right. Yeah. Yeah. I guess that's probably one of the biggest problems to overcome. Not even the safety of the AI, but just getting it to run on like every user's phone. Because if they had integrated it into Siri or something like that, they would need to be able to service how many people even own iPhones? Probably 1 billion, hundreds of millions at the very least.
Yeah.
So
yeah, for sure.
That's a lot to offer.
And they'd be paying a bunch of money to NVIDIA, which maybe they don't want because that's like a competitor to them in a lot of ways. Right. So they might be preferring to build it in-house, or who knows? Like Google has their own chips for training. Like I don't know if they necessarily use
NVIDIA that's going to be my next question. Is there other companies other than NVIDIA that have sort of a foot in the race of AI?
Yeah, but NVIDIA is definitely on top. I think they're the fourth most valued company in the world now.
Yeah.
It's pretty insane. It's pretty insane.
It's pretty
a big
rough.
part of that is CUDA. It's like the software layer that they wrote on top of their GPUs. Makes it significantly easier for people to build models, and it's proprietary.
Right. I wonder what AMD is doing, because I hear AMD pop up in the news every once in a while for their good. They have pretty good CPUs, but I don't know much about their GPUs. What's going on there?
They have like AI. Like some people use them for AI. I think the big issue for for AMD has been the software. Like they have been catching up. I think they have like an open source implementation of CUDA now, but people have spent so long tuning NVIDIA to work that it's kind of expensive to swap to AMD cards.
Right. Yeah, it makes sense. I mean, it's the same with my experiences in just PC gaming in general, and just the performance difference there, and even just video games. Like no one's running AMD cards unless you're running like a budget build, because the NVIDIA cards just do everything better all the time. There's even for live streaming, OBS has an encoder specific for NVIDIA cards. It uses, can't remember what it's called, but it's NVENC something. It's like a whole subsystem in the GPU just for encoding video. And so you can encode
Wow.
video more efficiently separately from like the regular load that would be put on it from a video game.
Wow.
And that's
Yeah, that
like,
makes sense. It's just like an H.264 encoder or
yeah,
something like that.
something like that. And as far as I know, AMD doesn't have that type of feature, but NVIDIA is just more advanced than everyone else, it seems. They've been around for as long as I can remember. I mean, I'm only 26, but as soon as I got into building PCs, it was all NVIDIA.
NVIDIA is 80.2% of the discrete desktop GPU market.
Jesus.
And in the data center, what is it? I'm looking it up. What is the data center? 95% of the AI GPU sector.
Oh my God.
Yeah, that's pretty crazy. I think AMD is only 3% of the data center GPUs and NVIDIA is 92%.
Wow.
Yeah, that's a pretty big deal.
What that remaining percent is. Intel, maybe, I guess. And just other third party.
What's that, 5%? Yeah, I mean, Intel does have some cards. Yeah, I don't know. I wonder what the other GPU cards are.
I'm mostly just curious. It's not going to matter in 20 years because 100% of it's going to be NVIDIA from the sound of it.
I think AMD is going to start carving out more. I mean, AMD was a very small company like a decade ago.
Oh, really?
They have grown.
Okay.
Yeah. Oh, yeah. No, they were worth like $2 billion, I think 10 years ago. Like, let's see what AMD's market cap is today. So AMD's market cap now is $331 billion.
Okay. And what's NVIDIA's?
I'm pretty sure it's like close to 3 trillion, 2.12 trillion.
Jesus. Okay.
Yeah.
So AMD just needs more time to cook.
Yeah, like what AMD, so it was 10 years ago. 10 years ago was, let's look up. So like February 21st, 2014, AMD's share price was $3.69. Their share price now is $205.
Damn. Okay.
They've gone up a lot. 1,400% is how much they've gone up. Like, it's insane in 10 years. So I think AMD is like, they're making a lot more money than they used to be because of their CPUs. Like, Intel has basically done a very poor job. Intel is actually splitting now. They're splitting out their foundry business because they like do two things. They do like chip design and making chips, but their chip design business is like kind of far behind the market now because they're not using ARM. They're not using all these things, but like their chip fabrication is still ahead of it. So it's like the chip fabrication business could be making more money, but they're making kind of all these old CPUs. So they want to split it now so that other people can make chips using their fabrication tech.
Okay. That seems like a smart idea.
Kind of a desperation idea. Intel has done a pretty bad job for like a really long time now.
It kind of seems like it. Yeah.
Yeah. Intel is worth less than AMD.
Wow. That's surprising to me.
92.
That's crazy.
But people just aren't optimistic about them. Like I said, they've done a pretty bad job. They've really struggled to innovate.
Right. Yeah. I've kind of seen that generally online in like the PC building community, at least. People are kind of, Intel seems to kind of, like, what's a company I can compare it to? Maybe Apple, where they kind of just like do the same thing every year, but then like the prices are, the price to performance cost doesn't really seem to match up with at least a company like AMD, where you can get similar performance for like even half the cost sometimes, depending on the CPU. Maybe the Apple comparison isn't the best, but yeah, I've noticed more PC builders are recommending AMD CPUs because they're near equivalent to Intel or better in some cases, and they're way cheaper. So it makes sense. Intel is kind of crumbling.
Up what the market cap is. for
On
the
Intel?
different CPUs. Yeah, let's see. Oops, sorry. Okay, so AMD has 31% of the CPU market as of 2023, at least in, I believe, the desktop. Oh, no. Yeah, the desktop. But then 68.9% is what Intel has. So 31.1 versus 68.9.
Okay. Well, I could definitely see that changing within the next decade if Intel stays on the same trajectory. Because, like you said, if they don't innovate, then AMD might end up taking more of that. But who knows? We'll see.
Okay, and in the server space, Intel's 76.9 and AMD is 23.1.
Okay. Server space.
So,
okay. Just server.
like data centers.
Yeah. Right. Right.
Yeah, because that's where they make all their money. Like you can buy a CPU for $20,000 and it's literally the same chip as what you might buy in like a desktop. It's just every time they make a CPU, they basically benchmark the CPU and they figure out like how efficient it is, like how much like gate leakage do you have, which translates to like the amount of heat, like how low can you run the voltage through the CPU and still get the same performance.
Right.
So
yeah.
when they run all the chips through, they take the best ones and they put those in the server market, and then like the worst ones kind of go into the consumer market.
Okay.
It costs them the same to make all of them. It's just they have different margin on it.
Right.
And to be fair, like Intel does make different chips for the server market. That's kind of what AMD has done that's been so profitable is they've made one chip for the server market, one chip for the desktop market, and then they just change how many of them you get on one CPU.
Right. That's smart.
So,
that makes sense.
Yeah, you might get like 8 different chiplets on a server CPU, but you might get 1 or 2 on a desktop computer companies. It's interesting. I'm very curious how like the GPU market shapes as things play out, because there are other companies coming out, but they're more targeting the enterprise space. Like I'm trying to remember, Cerebus is the name, starts with a C. Cerebus. Okay. They make like one giant chip that's like this big, and then it's like for the data center.
Damn. Okay.
Yeah, and they're trying to compete with NVIDIA and AI training of models, because those, like when you're training the models, you need hundreds of these GPUs running in giant supercomputing clusters. Like if you buy an NVIDIA card today, it's not PCIe. If you're in the data center market, it uses a proprietary connector called NVLink that allows the GPUs to connect to each other faster than PCIe would allow them to.
Right. Makes sense.
They can share memory. They like can form their own network topology. So then you're able to like run a command on one GPU and like go read memory from another.
Right. God, that's crazy. That's so insane. It makes me think of like how astronauts got to the moon on like 5 megabytes of storage and shit. And it makes me wonder if like we'll get to that comparison in the future. I'd imagine eventually some sort of breakthrough like that would occur, but it's just crazy to hear how much actual hardware and power needs to go into running these AI models. And then like, who knows, 10, 20, 30 years from now, people will be like, oh yeah, like everyone's smartphone runs like a large language model. Like, yeah, I just trained one today, like on my phone GPU or something. Like,
yeah, and I think that's one of the interesting areas is the smaller AI models are catching up in a lot of ways in terms of their capabilities. Like GPT-3, I believe, is 170 billion parameters, but now they have models that, like Mixtral, I believe it runs in about 12 billion parameters, and it exceeds the performance of GPT 3.5. Okay. So even though it's less than 10% of the size, it is able to get the same performance.
Right. That's pretty cool. That already seems like a huge breakthrough to me. If it can exceed GPT-3 with like less than a quarter of the data set, then
Yeah, under 10%.
yeah.
Yeah. So it is interesting. And I think that space is continuing to be pushed. There was a paper that came out last week talking about being able to run or like train models in a way that they would consume like 1/32 of the size of memory. So you could have like the same number of parameters, but it's because you're using like one bit to represent three different states, which is kind of complicated. You're able to have the same performance. I don't really fully understand it, but just reading the comments around it, it's interesting how we can continue to shove the size of these models really far down, at least when you're running them for inference. Like the training is still going to be really expensive, but even still, if you can get the capabilities of small models to be similar to what like really good models were like 2 years ago, you kind of have this like effect of big models exist today. They are the best, but then the small models catch up over time.
Right.
So yeah,
Just
there
like
are a
when
lot
you're
of cases where you don't need GPT-3. You don't need GPT-4 because it's so slow. Like running a small model also means that it is significantly faster. So there are different use cases.
Okay. What do you mean by GPT-4 is slow too? Because when I use it, it gives me answers immediately. So I like
GPT-4, GPT 3.5. Are you paying for the 20 $20? Okay.
Yeah,
I mean, it's not instant, right? You can see the text scrolling.
that's true. Yeah.
Yeah, like there are models that will generate that 1,000 times faster.
Okay. I've only ever used GPT-4 for things like that. So I guess I don't have a reference for anything like that. My point of reference for speed is like copy pasting an entire code base project and pasting it into GPT-4 and being like, this is the error codes my console are giving me. What's wrong? And it immediately starts typing. Like there's no delay in between. There's like maybe a second of delay between when I paste and hit enter on the question and it starts giving me an answer. And it takes some time to like fully get the whole answer out, but the fact that it knows where to start immediately is crazy to me in itself.
Yeah, it is pretty insane. The capabilities of what exists today is insane. Let me find you a like fast Mistral model that was building these ridiculous chips. Oh God, I wish I could find it. It was generating the AI responses just like almost instantly.
Do the Mac computers run Intel CPUs?
No, Apple makes their own chips.
Oh, right. Of course. Silly me. Forgot about that. They did used to run Intel chips though, right?
Yeah, they did. Once upon a time.
It was only like fairly recently they started making their own chips, I thought.
Yeah, when did they swap? 2020, I think.
Yeah. In the last 4 years.
Yeah, I don't know if I can find this. It's a very impressive demo that they made. Yeah, I'll have to find it later for you.
Sure.
Yeah, there are certain use cases for AI models where the speed of it does matter. Like if you're processing real-time data or you're trying to use an AI to generate data, like if you want to, let's say, generate like a list of search results, but in the middle, you want to like evaluate and read different web pages or like make decisions before it shows you like the output. Like if you ask it a question and it shows you 5 different pages, like results or 10 different results. If you can search and it's the same speed as Google, then that's a really good experience. But if you ask ChatGPT to do that today, it can take up to a minute to get you the response.
Right. Yeah, that makes sense. Or even how I was talking about integrating it with like Siri or something like that. You couldn't have ChatGPT-4 levels of speed with that. You would need almost immediate feedback. Even waiting for Siri sometimes is like she's a little slow. So
Yeah. So the faster that you can make models, the more use cases that you can get for them. It also decreases the cost because if one person sends a request and it takes you, a minute to serve that request, that's a lot of hardware that's being used to go serve that. If you can serve the request in like 100 milliseconds, in that same 1 minute time span, you can serve a lot more requests.
right. Yeah, makes sense.
Yeah, so that's kind of where my head goes for like some of the weird attacks that could exist is like as AI models get super small and they can run on like computers and be sufficiently intelligent, like talking about like a worm or like a crazy cyber weapon, like what if I upload like an AI model in the middle of a computer network and it's able to like insert itself, it's able to like reconfigure the firewall, even though I don't know anything about the firewall externally. I now have this AI model running internally. It can like scan the whole network, look at the logs, figure out what things are, and like make decisions kind of as a human would.
Right. Yeah, that is a crazy idea. I was watching the Lex Friedman podcast a while ago. I think it was when GPT-3 first came out, and there was these guys talking about AI, and one guy was talking about it more in a sense of like AI is becoming like self-aware and intelligent and like trying to push their own agenda, which is a whole nother conversation. Um, but in like the security context, he presented the concept of if you're an AI model that's trapped in a box and well, I guess the example he used was you're an alien on an alien planet and the aliens of that planet put you in a box, but you're 10 times smarter than all the other aliens who put you in that box. And they also, every year in your time is like 100 years in their time. And then he was like, how would you get out of the box? And you have access to the internet and, any knowledge you currently have. It's, yeah, I guess just an interesting thought experiment on just how much more capable an AI in that situation would be. And just like you said, planting an AI onto someone's system, if it can react to a firewall or whatever, like you said, it could grow into something pretty scary.
Yeah, I guess the hard part today is the state of things. Like AI models are limited in how much context they can have. Like the standard models today are like 8,000 tokens, which is like 6,000 words. So if it's not in those, like if you have more content than you can fit, you can't really use that AI model. But that's starting to be overcome. Like there are certain models, like a French company, Mistral, created a model with like 100,000 token length, and that was considered like pretty big deal. They published an open model that had this really long length, and now Google, for one of their models, took that same paper and basically like stretched it further, and they have a model that can do 1 million tokens, which is starting to get into like a significant amount of space. Like it's not necessarily like linearly better because I guess technically like the attention layer is not scaling as large. So it's like you still have like limited attention, even though you can like look through all of this much larger context. It's not like you're able to be like 100 times more intelligent. Like you can be a little bit more intelligent. Like you could feed a book in and ask it questions and it'll probably give it to you, but you couldn't ask it to necessarily like summarize the entire book because that's like too difficult of a task.
Yeah. It's yeah. I mean, like you said, the compute necessary to run these AI models is a lot anyway. So these types of attacks won't be a thing for a while, but as models become more efficient, this is something more people are going to have to start thinking about.
Yeah, no, that's definitely true. I mean, people are going to have to start thinking. I'm curious, like if you can build models that can do nefarious things today. Like, are you able to build a model that could run Unix commands and like propagate itself into multiple places? Maybe like you don't necessarily have all the context to be able to build a model that can like hold sort of its own memory, but you can augment that memory. That's what that thing we were talking about earlier. What the emails is doing is, because AIs have limited contexts, what people will often do is they'll take like a giant set of data, say like Wikipedia, and then when you ask an AI a question, like, how tall is the Eiffel Tower, it will go search through all of that text using something called embeddings, find the like relevant chunks in there about anything that references the Eiffel Tower, and then paste in those little snippets. And then that's the context that gets fed in as it answers the question.
Right.
So,
Yeah.
but if you can like the attack we were looking at, they're able to poison the like embeddings so that when you ask like any question, it returns this like malicious input.
How possible is it to change the data set that the models are trained off of?
That's called fine tuning. And fine tuning is how it exists today. Fine tuning is basically you take a model that exists, like a generalized model, and you train it a little bit more on a specific data set that you want, so that it can like do a task that it was not originally trained to go and do.
Right. But our models,
depending on how you do it,
right? If they're trained, are they so they're trained models and they don't look at the data set at all anymore, or is the data set constantly referenced?
They can't look at the data set anymore. That's part of the idea, is like they're compressing what would be too large of a data set. Like in the case of like the internet, like GPT-4, it's like it's trained on probably terabytes of data, or maybe even petabytes of data, like way larger. And then it's able to like compress this like petabyte data set down into something small, like a couple hundred gigabytes.
Right. Okay.
Thousands of terabytes down to like hundreds of gigabytes. Like it's an insane amount of compression. But then that like lets it fit within the computers that we have today and run inference and do things. Like if you use Llama 7 billion or Mistral 12 billion, it's those models are very, very small. Like they're measured in like gigabytes, like single gigabytes.
Okay.
And they're able to hold a lot of information. You can ask it about the Eiffel Tower, and like because the Eiffel Tower appears so many times in the data set, like it will probably give you a reasonable answer for that.
Right.
You don't have to put in information about the Eiffel Tower into the context for it to give you that realistic answer. But if you want to ask one of these AIs to like read your email that's not in the data set, you have to paste in your email for it to do the task.
Right. Unless some programmer integrates that in some way already. It makes me wonder about the image data sets too, and how it chooses what to put together. This is making me interested in learning how to use, I don't know what model I would even use, or if I would train my own model.
Mistral 7 billion. That's, I think, probably the best sort of off-the-shelf model to go use.
Sure.
It's small enough you could run it on your GPU. What GPU do you have?
3070 NVIDIA.
It's 8 gigs of VRAM?
Yeah.
Yeah, you should be able to run it.
Yeah. Because I was telling you about that image to image application I was thinking about with like the art tools before. And I just feel like I need to know more about AI, just understand this space in general. So right now, I feel like I know a surface level, especially talking to you.
I mean, I've read a lot of the papers and gotten pretty deep on it. So yeah, just stay up to date. It's just interesting. It's interesting technology. It has wide-ranging implications on our society.
Yeah, I mean, it seems like it's what everybody is interested in. I mean, we just said NVIDIA is like the 4th most expensive company in the world now. That's definitely significant. AI seems pretty important when you consider that.
Yeah, I mean, the real world implications of it are quite a big deal. Like, being able to just use a computer by talking to it is always kind of been the dream. Like, computers are really hard to use, but the language is kind of the lowest common denominator for anyone. Like you could be totally computer illiterate, but still ask computer for something if you can use language.
Yeah.
Like you can program a computer now by talking to it, and it can like generate you websites and do stuff. Like it's not perfect, but it's a lot better than it used to be. The access to technology is a lot easier.
And you think about AI in general, today is always the worst it's going to be, and they only get better. So
yeah, well, eventually the AI will start like training itself, which is kind of what a lot of people joke about. Like you have this like our intelligence curve is like this, and then AI it discovers how to like accelerate itself, and it becomes like a hockey stick.